Hello there, and welcome again to the shop. Over the last few videos we've had a close look at how to get the correct cut on some different materials, and we've also done some engraving or etching. So today we're going to put some of that cutting and etching into good use. So I'm going to show you how to make your first finger joint box. So to do that, there's no need to go into a CAD system and draw all the individual finger joints accurately to get them to fit into each other. We're going to use a free program which is dedicated to making these types of projects for you. And they're freely available for you in Google. So let's take a look on the big screen. Okay, so we'll hop into Google, and what I've put in here is free box generator. Now there are a number of them that will come up, but the best one I have found to use is this one here, which is boxes.py. So now the program is very simple to use, and it's a very versatile program. You can make hundreds and hundreds of different projects with it. All you need to do is put in some simple measurements. But the first job that you must do with your laser is to do a couple of test cards with this program. It does it automatically, and all you do is run the program in the laser via light burn. So what we need to do, we need to make some test pieces to find out the best fit for our finger joints. You know, they can't be too tight, they can't be too loose. They've just got to be right. You've got to get them in the Goldilocks region. So to get our test pieces, I'm going to open up parts and samples. And we're going to choose burn test, which will bring up a wizard or dialogue that we'll fill in. Okay, so this is very simple to fill in. So what we're saying is this is in millimeters. Okay, you are able to adjust this into inches if you wish, but I always work in millimeters. So it's 100 millimeters, which is about 4 inches. So it's going to be 4 inches square, which is fine. The degree in which the joints are going to increase, okay, after each test, all right, is 0.01 of a millimeter, which is fine. We're after a close fit. So we're going to leave it at that. There's going to be 2 pieces. The material is 3mm, which is what we are using. Now you will need to save this file as a DXF. For some unknown reason, when you transfer it into Lightburn, a weird thing can happen with any lettering. So DXF, no problem at all. Tabs, we don't want tabs. Labels, yes, we want the labels because we want to identify which parts will fit together easily. So it's going to be numbered. Reference, I'm going to alter that to 0. inner corner loops, I'm just going to put that as corner. Okay, so this figure here is quite important because this is the burn correction. In other words, this is the degree in which the line in between the finger joints is going to be adjusted on each test. So that's a little coarse. Now I think probably half that. So I'm going to go 0.5. So that's 0.05 of a millimeter. Okay. So that will be the burn correction. So we're going to say generate, and that will download to my downloads file. Which I don't know whether you can see off camera down here. You can just about see that. It's downloaded to my... Is it finished? Yes. And we should find that in the folder. Let's have a look. Show in folder. There it is. There. Okay, so what I'm going to do is drop out of the internet. And I'm going to drag and drop that onto my desktop. So now I shall transfer that to the computer that is on the Thunder Laser. Okay, so I brought that file into Lightburn, and we'll just enlarge that, not too much, so we can see what we're doing. So as it comes in from that program, it comes in all as one color. So we need to assign the write-in to a different layer or different color. So what I'm going to do is hold the shift key down and encircle that write-in. So see, it goes a bit sparkly and you've still got handles around it. So I'm going to come to this one and do the same here. With the shift key held down all the time. In actual fact, what we can and these, put my heads out of the way, and these, I think I've got them all. Yeah, they're all sparkly. Yeah, we got them all. Release the shift key now, and I'm going to assign those to a blue layer, and I'm going to group those. Into one selection and deselect it. Okay, so I've got two layers now, and what I normally use, rather than a black layer, I'm going to select these. That's that one, that one, that one, and that one. I'm going to put those on a red layer because then you won't get confused. And I shall, I don't know what happened there. So I shall group those as well. And deselect it. So now we have our two layers here, and they are in the right order. Now it's necessary to etch these, the writing in first, then cut out last. Okay, so the writing is a fill, that is a line or a burn. So we'll do this one first. Speed 100 millimeters. Actually, we can probably raise that up to 200 millimeters quite safely. Probably go further than that actually. We'll go 250. So that's 250. 20 might be a little bit much with a. I'm going to knock that back down to approximately 15. Actually, what we're going to say is 16. Minimum power, we'll say 10. I'll say 12 actually. I haven't done much engraving with the Thunder laser. I've only actually done one engraving, and by what I've seen, we don't require much power to do it. So we'll leave it at that. Air. If I toggle this to no air, the Thunder laser will do a low blow. It has 2 air blowing settings, and if you select air off, it automatically goes to the default of low pressure air, which is what we require to fill. This is only a. I think this will be fine actually. 0.1 is fine. It's going to be fairly detailed at that. It's only a test card. Lines per inch, that's fine as well. Scan angle, we're not going to worry about any of these. And we're going to do a single pass. And that's going to be okay for that. And this second one is a burn. That's going to be a little fast. So what we're going to say is, I think I'm going to run this at 20 millimeters, about 3/4 of an inch. That'll be fine. It's just over 3/4 of an inch actually. Oh, too many zeros. That'll do. Max and min power, I'm going to say 50 actually. Like I say, even the cutting is fairly new for me, but by what I've seen, I think 50 will be fine. 50 by 50. It's a line. High pressure air, that will be fine. I don't need to alter anything else. I'm going to say OK. So I'll connect this up now to the laser and put some material in there and set it up to burn. Okay, so to do this project I have quite a large-ish sheet. So I'm going to need to take this front panel off. Very easily done. Ooh. That is really heavy gauge material. That's fairly heavy. So to operate the Z is very easy with this new type controller, because it's actually on the controller. Up we go. Okay, so I'll just get my sheet and we'll put it in and set the automatic Z. Now to focus, what you need to do is press menu, and the first listing highlighted that comes up here is focus, so you just press enter. it is. Okay, so I've set up the datum just there. Let's square the sheet up a little. I'm just going to do a frame test. Yeah, I think that's okay. Alright, so let's run it. Lasers on, and we will start. Right, so I've cleaned them up a little. Now, what you need to do is match these up together. Oh, that's very loose, so that's 0.05. Let's try 0.06. That's still loose. 0.07. Still loose, but I can feel it's getting a little tighter. I'm doing this with a 2-inch lens as well. Still loose, but getting a little better. Let's try these. What do we got here? 0.09. Still loose. I can feel it getting a little tighter though. 0.1. Oh yeah, starting to be an interference, a slight interference fit. 0.11. Yeah, it's like a magnet's got hold of it. 0.12 is probably. That's not bad, actually. So toss up between that one and the I think it's going to be this one. That's not bad. I think that's going to be the one. That's a nice fit. It feels like a magnet's got a hold of it. So that's the number we're going to run at. 0.12. So that is how you find out what your laser, should we say it's a burn offset for the finger joints is going to be. And my particular laser, which is a Nova 3500 watt with a 2-inch lens, that's what it is. Okay, so I think what we're going to do now is we're going to jump back into that program again, and we're going to design up a small tray box that we can put together to be a bit of an organizer, I think, on top of the laser here, because I've always got magnets or something hanging around on the top and I'm forever knocking them off. So okay, we'll design it and we'll cut it out on the laser.